A prime number is a number divisible by 1 and itself only. I've written out the numbers 2 to 15 here, primes in green, and numbers that are not prime, composite numbers, in red. They're called composite numbers because they are composed of multiplication of prime numbers. Let's look through a few examples so you can see what I mean. 2 is divisible by only 1 and itself, so 2 is prime. 3 is divisible by only 1 and 3, by 1 and itself, so 3 is prime. 4, on the other hand, is divisible by the prime number 2, so 4 is composite. 5, divisible only by 1 and itself. It is not divisible by 2, 3, or 4. 5 is prime. 6 is divisible by 2 and 3, so 6 is a composite number. And if we wanted to write what's called the prime factorization of 6, we would look for its component parts. 6 is a composite of the multiplication of the number 2, the prime number 2, and the prime number 3. 7 is prime because it is not divisible by any preceding number other than 1. 8 again is composite. 8 can be divided by 2 or 4, and 4 itself can be divided by 2. So we would find our prime factorization of the composite number 8 by continuing to decompose 8 into its constituent parts. 8 is the product of 2 and 4. 4 is the product of 2 and 2. So, our prime factorization for 6 is 2 times 3. And our prime factorization for 8 is 2 raised to the third power. 9 is a composite number because 9 is the composition of the prime number 3 times itself. So the prime factorization of the composite number 9 is 3 squared. 10 is a composite of 2 and 5. 11 is prime. 12 is a composite, can be divided by 2, 3, 4, and 6, but 4 and 6 are composites, so they can be decomposed to their prime constituent parts. And you can break down the multiplication however you see fit. You can do 2 and 6, and then break down the 6 to 2 and 3. Our prime factorization here is 2 squared times 3. Or you could take the composite number 12 and begin breaking it down with the multiplication 3 and 4. But notice how you're going to end up in exactly the same place. Break down 4, because that is the composite of the prime number 2 and 2. So once again, we end up with a prime factorization of 2 squared times 3. Let's do a much larger example before I cut you loose to work on the assignment. To decompose a larger composite number, like 72 for this example, you need to just think through your mind what numbers will divide evenly into 72. You might see 2 and 36, you might see 12 and 6, you might see 8 and 9. I think 8 times 9 is 72, because 9 times 9 is 81. So this is a really good place to practice your mental math and also understand a little bit about how numbers are created. Every number is a composite of primes, and it is a worthwhile exercise to determine what the exact nature of that composition is. So I'll start with 8 times 9. And notice 8 and 9 are both composite numbers themselves. So let's break them down. 9 is a product of 3 and 3 is prime, so we're done. 8 is the product of 2 and 4, but 4 itself is composite, so we decompose 4 into 2 times 2. So our prime factorization for the composite number 72 is 2 raised to the third power times 3 raised to the second power. That should be enough to get you started on the page.